Hey guys, this is Mr. Kelly. This is Precalculus. This is the video kind of linking our day 2 with the review. So day 2 we had 8.3 and you worked on we introduced hyperbolas. That was 8.3. But we didn't quite get all the way that I wanted to. So for those of you who first of all missed this day for it was the SAT, right? Might have missed for the SAT, and for everyone else, this lesson is going to kind of bridge you to make sure you're ready for the review and then ready for the unit assessment. So definitely watch this between now and the review day and do the delta for 8.3. Okay. All right. So let's get to it. So again, I'm going to start where we began in class. So if you've already seen this in class, you already have the notes for this section, just like skip ahead in the video, okay? Just go to where you don't have notes, okay? So first of all, what is a hyperbola? So a hyperbola geometric definition is a set of all points whose distances to two fixed points called, again, foci, subtract to make a constant value. So in ellipses, right, they add to equal a constant value. In hyperbolas, they subtract to equal a constant value. So say, for example, that this constant value is 4. That means the distance from one foci to the minus the distance from the other foci will be equal to 4. Sorry, the distance from one foci minus the other distance will be equal to 4. The difference between the two will be 4. Okay. So, what does this look like? Well, these are foci, F1 and F2. We have also a vertex, 2 vertices, one here and one here, for example. Now, why is this true? Well, if the distance is 4, right, then this distance from this point to this focus, that could be 5, but the distance from this to this could be 1. So 5 minus 1 would get us 4. I'll show you that with another point. We might have a point here where something similar happens, right? This distance here from focus 1 to this point, and this distance here from focus 2, this could be 5, this could be 1. 5 minus 1 is 4, so this point would work. So what we get when we draw out the hyperbola and find those points, we get kind of a double parabola kind of shape, okay, where you have two mirrored parabola shapes, U-shapes that are going away from each other, okay? So in the center, you still have what's called the center, and the axis of symmetry that divides these curves in half, like the axis of symmetry, is called the transverse axis. Transverse axis. And then perpendicular to that, we have what's called the conjugate axis. We have the vertices, we have the foci, transverse axis, conjugate axis, okay? So we have two equations to write hyperbolas out. We have one, x squared over a squared minus y squared over b squared equals 1, and the other, y squared over a squared minus x squared over b squared equals 1. Now, what's the difference between these two equations? They look really, really similar, right? Well, the difference is what we're subtracting. If you look on the left here, we're subtracting y squared over b squared, and over here we're subtracting x squared over b squared. That's the key, and that tells us how they look. If it's x squared minus y squared, it will be going out to the left and to the right. If it's minus x squared, we'll be going up and down. Okay. The way that we find the vertices is through the A. Now the A does not have to be larger than B. Remember in the in ellipses, like A was the larger of the two numbers, and that sort of told us if it was wide or tall. Remember that? But in this case, that's not quite how it works. No matter what, whether a or b is bigger or smaller, a will always tell us the vertices, and a is the value underneath that positive variable. It'll be plus minus a comma 0. And on the other side, because we're going up and down, it'll be 0 plus minus a. The foci, the relationship is c squared equals a squared plus b squared. Classic Pythagorean theorem, right? And then the location of those foci will be plus minus c comma 0 and 0 comma plus minus c. The transverse semi-transverse axis, that means half. So half the transverse axis is a, and half the conjugate axis is b. I'll go back and label that. So this length is b, that's the semi-conjugate here and here, and this length is a. That's this and this, okay? The asymptotes we find by y equals plus minus b over a if it's going left to right, and then y equals plus minus a over b if it's going up and down. Okay, let's do an example problem. It's a lot clearer when we put numbers instead of letters. So let's try one. X squared over 9 minus y squared over 16 equals 1. All right, so first of all, the first thing you want to decide is, well, which direction is this going? So since it's minus y squared, if you look back at our notes, right, minus y squared, that is side to side. It's going left and right. So we go open left, and we'll open right. Let's not get that wrong. We make sure you get that right, okay? Now, again, the a squared is always underneath the positive. It doesn't matter if it's bigger or smaller. This is my a squared, and this is my b squared. Okay, so that means, well, a must equal 3, b must equal 4, a squared plus b squared equals c squared, so c squared would equal 25, and c would equal 5. So we found our a, b, and c. Now we're going to plot. In our current examples, for right now, our center is at 0, 0. So this is our center right here. And we're going to build from there. That's kind of our base, right? So to find the transverse axis, we're going to go a to the right and a to the left, right? 1, 2, 3, 8. That's going to get our vertex. And I know that because it's opening left to right, right? These are going to be my vertices here. And then up and down, 1, 2, 3, 4. 1, 2, 3, 4, that'll be our conjugate axis. And this helps us build this kind of rectangle. It is not kind of a rectangle, it is a rectangle. Using those, that transverse and conjugate axis as a grounding point, okay? So we know, it's going to look like this, like, your hyperbola is going to go out in this direction, but what kind of angle? Will it be thin? Will it be wide? How do you know that? Well, you figure that out from what are called the asymptotes, right? If you remember from asymptotes, way back from rational functions, right, when we had some number dividing by 0, we'd have these asymptotes that the function would approach, but it wouldn't cross, right? Well, all depends on the type of asymptote. But if we have, for example, vertical asymptotes, the y value shot up to infinity and negative infinity at that point, and it didn't cross over, right? Well, that's kind of what's happening here. The hyperbola is going to approach this asymptote on either side, but we're not going to cross over, okay? It's telling you the behavior of the curve as we go to positive infinity, negative infinity. Okay, so that's the rectangle. Those are the asymptotes. The vertices. So let's start listing some things. So vertices would be 3, 0, and negative 3, 0. The foci, because c is 5, they're on the same as the transverse axis. That would be negative 5, 0, and 5, 0. And then the asymptotes themselves have equations. So the equation of this asymptote, remember that equation of a line is y equals mx plus b. The equation of this asymptote would be up 4 over 3. So it would be y equals 4/3 x. So again, the way I got that was, you can pick 2 points on the line and then find the rise and run between them. So we'd go 1, 2, 3, 4 up, 3 right. So here, this line, we go 3 right, 4 down, so that would be y equals negative 4/3 x. Oop, can't see that. There we go. Okay, good. All right. So that's an example of a hyperbola. Let's take a second for you to try. So again, if you are doing this at home, maybe this is maybe where you're picking up the video. If you already saw the lesson, try this one and check your answer with me. So I'm reading it. I'm subtracting x squared. That means I'm going up and down. Okay, my a is 3. My b is 4. Since these are both 9 and 16, that means my c is 5, right? 9 plus 16 is 25. C squared equals 25. That's how I know c equals 5. We're going to make our rectangle. This time our vertex, because we're going up and down, the transverse is vertical, right? So I'm going to go up 3, down 3, right 4, left 4. Make that rectangle. And then draw the asymptotes for the straight edge, comes in handy. All right, and sketch. I am rushing, not rushing. It's going up and going down. There we go. Don't make that mistake that I was about to make. Okay, and then vertices. So vertices would be at 0, 3 and 0, negative 3, and the foci would be at 0, 5. And 0, negative 5, right? That's C up and C down from that center. Okay, that's it. And then the equations, the asymptotes, we'd have y equals, this time instead of 4/3, it's 3/4 x, and y equals negative 3/4 x. So when we're centered at 0, 0, they're fairly straightforward, right? Nothing too much to worry about. To solve these ones here, and we'll get to this in a bit, but just so you're aware, we just need to make sure it equals 1, so you divide both sides by 144, and then we simplify those fractions. So 144 divided by 4, 144 divided by 4 is 36, so this would be the same as x squared over 36, and then 144 divided by 9, and then minus y squared over 9 equals 1. So you got to make sure that equals 1. Okay? That will cover that first day. Let's look at the second day, though. So when we change the center, that does change things a little bit. So this is when things get a little more complicated. We just add that h and k to the numerators of our equation, right? So again, the center will be at h comma k for both of these, but we will have y minus k squared over a squared minus x minus h squared over b squared equals 1. Or x minus h quantity squared over a squared minus y minus k squared over b squared equals 1. Okay, so the same as the previous equations, you just got the minus k and the minus h to change the center. Everything else is exactly the same except the center is different. And so that is like how we build the hyperbola changes in that way. So but everything else kind of stays the same. So here we look at, what are we subtracting? Well, we're subtracting y squared. If you remember, subtracting y squared, that means left to right. Subtracting y squared means left to right. So we're opening left to right. Let's get our center first. I would say, like, before finding the center is just check the direction. So I'm just going to do a little sketch of that. We know it's left to right. The center here will be negative 1, 4. Make sure you're looking at the right x and the y, right? H goes with x, k goes with y, and remember, you're assuming it's negative, so take that into account, right? If it's positive, it's really -1, whereas if it's already negative here, you know it's the positive 4. And then we will make the rectangle. I'm just going to go ahead and name the 4, a equals 4, b equals 3. It's that same pattern. C must also equal 5. Let's plot. Negative 1, 4 is our center. We're going left to right, so I'm going to go 4 right, 1, 2, 3, 4 right, 1, 2, 3, 4 left, up 3, 1, 2, 3, down 3, 1, 2, 3, rectangle, left to right, asymptotes. Let's get the asymptotes. Okay. All right. And then we can sketch, right? Just gonna look something like this and like this, this and like this. Pretty straightforward, right? Now, the one part, one, two, three, four. This is my focus. 1, 2, 3, 4, 5. It's my focus. The one part that's a little different here is the equations of the asymptotes. So center is the same, ABC, that's all the same. Again, the relationship for C is C squared equals A squared plus B squared. That's how I know C is 5, because it's 25 equals C squared, which gets me C equals 5. The vertices, those are just on the ends of the transverse axis, right? And the foci also line the transverse axis, so that's why I'm going 5 out from the center there. So let's label some things here. So my vertices are 3, 4, and negative 5, 4. And then my foci are 4, 4, and negative 6, 4. Okay, so the last really tricky part is, well, what are the equations of these two lines? And you might remember from before that you look at 2 points and you find the rise or run. So you might say, oh, this is just y equals 3 over 4x, right? Like you told me, 3 over 4x. You can see that. But that, unfortunately, is not right. That is not it, right? Because if it was 3 or 4x, it'd be going through here. So you need to alter this so that the y-intercept matches. So one way you could do that is to find the y-intercept. But the easiest way to do it is to use what's called point-slope form. Remember, point-slope form is y minus y1 equals mx minus x1, meaning that's your slope, then this is some point that's on your line. And remember, you know that the center, that is a point on your line. So we kind of combine these two things together. Well, you know the slope is 3/4 x, right? So we're just going to, the 3/4 goes in for m. And then for x1 and y1, we can use the center because we know it goes through the center. So this would then become y minus 4 equals 3/4 parentheses x plus 1. That is the equation. So that's not right. This is the equation of that asymptote. And this one similarly would be y minus 4 equals negative 3/4 x plus 1. Okay. I will do another example of that just so it's super, super clear. But I hope that made some sense. Let's do this bottom one for practice. So hopefully you feel good. Why don't you try this one? Okay, why don't you try this one? And just pause the video. In a second, I'll do it. Okay, so we're back. We're going to do it. First of all, direction. This is up and down. I know that because it's minus x squared. Next, Center. Center is negative 1, 2. Okay, let's plot that. Then A is 3 and B is 4. A won't always be in 3 and 4. We'll go up 3, 1, 2, 3. We'll go down 3, 1, 2, 3. We'll go right 4, 1, 2, 3, 4. We'll go left 4, 1, 2, 3, 4. So we got transverse going up and down, conjugate going left and right. Went a little too far there. We'll get those asymptotes. And we'll sketch. Get asymptotes to the corners. To the corner. And then sketch. Again, it made a little mistake. This is up and down, so it's going this way, and this way, and then this way, and then this way. Ignore that squiggle to the right. Okay. I hope that's straightforward, and I think you can understand that. Okay. Let's look at those asymptote equations, though. So again, it's y minus y1 equals mx minus x1. You just need to find the slope, and then you know the center already. Well, what's the slope? The slope is 1, 2, 3, 4 to the right, 3 up. So m equals, it's going to be plus minus 3/4 right. That's your slope. For your x1 and your y1, you can just plug in your coordinate negative 1, 2, right? That's your center. That's it. Okay, and I put that plus minus there to show both. Okay, let's take a look at some working backwards problems. So here that, you might be given some information, but you'll have to work backwards to find out what it was. Let's take a look at that. So, for example, okay, we have foci here at 0, 3, and 0, negative 3. So I know that we're going up and down. And I know the transverse axis length is 4. So I know my C must be 3. My transverse axis length is 4. So that means this is my transverse axis here. So that means if my transverse axis length is 4, remember that's 2a. That means that a must equal 2. So that means 4 plus b squared equals 9. That means that b squared must equal 5. That means that b is root 5. Root 5 is just like a little bit over 2. So that would be just over here, back here, and then draw that rectangle. And then we can sketch from there, right? We know, because we know the foci are on the transverse axis, this must be going up and down. Oh, my bad. That should be going there. Because this is the vertex here. This is the focus. So it would look like that, and then we would cross the root here, like this, and like this. And then we'd be taking it from this value up, and this value down. Okay. Let's take a look. Let's do something different. Let's do this one down here. Foci is negative 3, negative 8. Okay, we'll plot that, and then negative 3, 3. Okay. So remember, your center's got to be in the middle of these two. So the distance between negative 3, 8 and negative 3, well, that's 11, that distance. So we'll be right in the middle of that. So 11 over 2, that's 5.5. So we're going to go 1, 2, 3, 4, 5, and a bit. This has got to be my center here, because it's got to be in the middle of the foci. The transverse axis endpoints are negative 3, negative 6, and then negative 3, 1. Okay. All right, so that means my A would be 3.5, because this distance here is 3.5 away. This distance, again, was 5.5 away. So that's, C would be 5.5. So this is going to be a bit of an ugly number, but it would be 3.5 squared plus b squared equals 5.5 squared. We'd solve that for b squared. That would be, let's see, 5.5 squared minus 3.5 squared is 18. So b squared equals 18. That means b equals root 18, which is 3 root 2. Right, because it's 9 times 2. So that's root 9 is 3, so it's 3 root 2. What is that roughly? What's that roughly? It's a decimal. It's 4 and a bit, 4 and a quarter roughly. So if this is our center, we'd go 1, 2, 3, 4 and a tiny bit. And then 1, 2, 3, 4 and a tiny bit. And there we have our rectangle. And again, because this is the transverse, we know it's going up and down. And then we can sketch. And we can sketch. And then draw. Okay, hope that was helpful. So now take a look at the Delta homework. That will kind of close the loop in terms of hyperbolas. You're going to have to kind of find the vertices, find the equation of the asymptotes, find the foci. You're going to have to write the equation given features. You're going to have to graph them from conic form, and then you will also have to use that completing the square skill that we learned in the ellipse section. So what I'm referring to there is for those questions, this is at the end of the Delta, you'll see this kind of question, right, where we have in conic form. So this is the exact same process. You're going to use your notes here where you complete the square, clear the constant, right, group the terms, add b over 2 squared to both sides to get it in that conic form, and then sketch it. Okay, so please spend the time doing that work before the review period, and I will see you there. Okay, bye-bye.